So what's a polyatomic ion? Who remembers what the prefix poly means? Multi or many. You know what? These are ions. They have a charge, but they're made up of more than one atom. And so what I really do, Cole, is I treat these things on the back of your sheet as one weird, funky atom. I treat them as one strange atom. They behave like that. They're bonded covalently, but then they combine ionically with metals and nonmetals. There's only one polyatomic ion that's well, you know what? Let's fill in some notes. It says this. Polyatomic ions, you know what, Mr. Duick? This is what I need, I think. There we go. No, this is not what I need. Hang on, I got to pause my video for a second here and get organized, Mr. D. Pause. So let's continue after that little mishap. Polyatomic ions act as a group. You know what? I've decided with the blue background, using blue ink isn't smart. Let's go red. And they can bind to single atom ions, or they can also bind with polyatomic ions. Now, so far this year, Ibrahim, there's only one positively charged polyatomic ion, ammonium. So the only time that you might get two this year, polyatomic ions combining is if ammonium, that positive, combines with some of the negatives that are right next to it in that chart. Okay? Just again for nerd trivia, the atoms inside the polyatomic ion itself are held together by covalent bonds. But the polyatomic ions form ionic bonds with other atoms. In your notes, it says see table. You know what? The back of your periodic table is the list of common polyatomic ions. It does say a complete list. Actually, no, there's many, 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 many more than that. But these are the ones we're going to use. Okay? And again, do you need to memorize these? Nope. There's a pretty easy way, Mason, if they give you a chemical formula. If you're dealing with a polyatomic ion, you can tell, you just count the number of capital letters. You count the number of capital letters. If your formula only has 2 capital letters, there's no polyatomic ions. And that's going to be just your regular naming rules, or what we called the IDE rule. Oh, if it's multivalent, you might need Roman numerals. If there's more than 2, it's a polyatomic ion. In which case, you're not going to use the IDE rule. You're going to use the name that's on the back of your pink sheet. Use name on sheet. Let me give you an example right here. I don't know if, I don't have one yet in your notes, so we'll just make one up right now. For example, if I went, NaOH. What's the first thing? What is Na? It's a metal. Cool. How many capital letters do you see here? 3. This is going to be a polyatomic. So I would not call this sodium oxide no. I would say sodium. Then I would go find OH on the back of my sheet. What is OH called? This is called sodium hydroxide. Or if I saw Mg and that one's pretty obvious that we're dealing with a polyatomic ion. But again, Matt, same rule. How many capital letters do you see? More than 2. This is polyatomic. Mg is magnesium. I would not call this magnesium chromide dioxide. You know what? I would look up what's the name for Cr2O7 on the back of my sheet.
Chromate.
This is magnesium chromate. Chromate? Yeah?
Oh, wait,
No.
Dichromate.
Dichromate. This is magnesium dichromate. By the way, di means two. How many chromes do you see in this polyatomic ion? Two. As opposed to straight chromate, which is how many one. Now you're also learning a little bit about the covalent naming convention. We use prefixes like di and tri and tetra and mono to tell you how many of each there are. That's when it's covalent. What if they gave me hang on, that's wrong. Let's go like that. NH4. What is NH4? Ammonium. Okay. You would read this as ammonium. Now, P, is that a polyatomic ion on the end? Say no. So, what do we do with phosphorus? Now we bring in the ide rule. Yeah, what is it? So what would you call this? This is ammonium phosphide. Okay. By the way, what's the charge on phosphorus? Its ionic charge is 3 negative. How many ammoniums did I need? And did you see I had to put it in brackets? How many ammoniums did I need? 3, because each one has a charge of 1. You can get good enough, it is possible, Nick, to get good enough to kind of do these crisscross in your head like I just did. On a test or on a quiz, I almost always write it out carefully, do the crisscross thing to make sure I have my ratios correct. Is that all right? So, let's keep going. For me, it's turn the page. Oh, I asked the cat sitting next to me if he had any sodium hypobromite. He said, nah, bro. No? Okay. I told a chemistry joke. There was no reaction? No? Oh, tough audience. Tip your waitress. Try the veal. So, let's put it all together. Writing the names of compounds that include polyatomic ions. Again, first of all, the names of polyatomic ions, you have to get it in here. Come here, Mr. Duke. Don't change. So you don't have to change their endings. You don't have to. Some of them might have an "ide" ending. No, you actually know none of them will have an "ide" ending, because if they had an "ide" ending, they'd be an element. You'll see a lot of them have "ite," I-T-E endings, or "ate," A-T-E endings, or stuff like that. But most, you don't have to change their endings. You just rewrite it. Okay? So you don't have to. Oh. Let's see if my pen is now working. It is. My pen had stopped working for a second there. So you don't need to change endings. Really, I think recognizing that a polyatomic ion is present is the hard part. So, remember, count, capital letters. More than 2, you're dealing with something polyatomic. Only 2, that means you've got 1 metal and one non-metal, and it's ionic. So more than 2 means a polyatomic ion. All right, let's try some of these. I gave you guys a little chart, I think. Yeah, 4 of them there, right? Name these compounds here. So I would first of all say, ding, 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 ding. I see more than 1 capital letter. This is ionic because it's starting with a metal. What would you call this? Sodium. You have to say the last part carefully. I just didn't hear. Because there's 8, there's ite, and there's ide, and so you have to just, sodium sulf.
8.
Is it 8?
Yeah.
A-T-E? Sodium, is he right? Okay. Sometimes you'll see the sulfate spelt with a PH. Sometimes you'll see it spelt with an F. Apparently, sometimes I flip-flop. Nice yawn. What would I call this one here? Yeah. Come on, Mr. Duke, learn to type. Calcium nitrate. Not nitrite, not nitride. And this is where it gets tricky because unfortunately, go figure, Hannah, it's pretty easy to get nitride mixed up with nitrite, mixed up with nitrate. And so all I can say, Josh, read really, really carefully. Did I give you a chart, though, so you don't have to memorize them? Well, okay, we'll take that. What's this one here? Ammonium what? Oh, chloride. Now we'll bring the ide rule back. So this would be ammonium chloride. Not to be confused with chlorite or chlorate, which are also on your sheet somewhere. How about this? Magnesium. Yeah. OH is hydroxide. I think that's the only polyatomic that you guys have that ends in an I. Oh, I guess hydrogen sulfide or bisulfide. Oh, and cyanide. Okay, there's a couple that end in an ide. Most of them end in ates or ites or other weird stuff. Is that okay so far? The naming, Matt, isn't too bad. The writing the formula, well, this gets a little yuckier. So let's write some formulas. Oh, did I give you those ones as well in your notes? No? No? Let's do these really quickly together. Na2SO4. Did I do that one already? I did. And you know what? What would CaCr2... Okay, here we go. Here's some new ones. What would this one be? CaCr2O7. Hannah, go ahead. Dichromate? Ite, or I don't have these memorized. Cr2O7. Dichromate. So calcium dichromate. What about BaCN? Yeah, I like this one. Yeah.
Barium
Cyanide. Barium with cyanide. Oh, no. That almost sounds like you're trying to do it with it, right? Okay. Barium cyanide. Next one. I'll give you a hint. Potassium. ClO3. Is that ite or ide? I know it's chlor something. Trev. Chlorate? Not ite. You said ate, right? AT? Yeah. So you can see it's really easy to make a mistake if you're in a rush, Maddie, so just be extra careful is all I can say. Sorry? Someone said it. Ite? I-T-E? Is that right? PO4 is ite? Is it fate or is it fight? Ite. Phosphate? Yeah, okay. Copper. Ooh, got a problem with Cu. Cu is multivalent. So is Fe. This is where it gets pretty tricky. How tricky? So tricky that I'm going to pause and deal with it. I'm going to come back to copper. I'm going to come back to iron. Because this is yucky, this is tough. This is yucky, this is tough. Carter, you gonna make it? That was a long blink. It really was. Okay. Back to our notes, I think. So, writing formulas including polyatomic ions. What you're gonna do is you're gonna treat the polyatomic ion as one group. You're gonna treat it as one weird funky ion. That means if you need more than one of them to do your crisscross, to do your balance, you need to put brackets around the entire polyatomic ion. Say, what? I'll show you what I mean. Let's suppose I want to write sodium hydroxide, the formula. First thing I'll do somewhere off in the margin is I'll write sodium and I'll put its ion charge. What's the ion charge on sodium? +. plus 1. Then I'll write hydroxide. What is hydroxide's symbol? OH. What's the charge on hydroxide? Oh, now when I crisscross, you know what, Hannah? That one's going to work out real nice. The formula is just going to be one of those, one of those. If there's only one, do I need to write, Franz? Do I need to put the ones as subscripts if there's only one of? No, okay. Okay. Magnesium phosphate. Okay, I would go Mg. What's the charge on Mg? Phosphate. I have no, you know what, this one I gotta look up. PO4, 3 negative, yes? So I'm gonna go like this. PO4, 3 negative. Now when I crisscross, it looks like I'm gonna get what number beneath the magnesium? It's gonna be a 3 there. What number down here? Now to show that I need 2 of those completely, I'm gonna have to do that. When I write the formula, it's going to be Mg, 3 of them, PO4, close bracket, 2 of those. So, you ready? For a candy, how many atoms make up that molecule? So far, no one's been correct. Nope.
9.
So you ready?
10.
You ready? In math, when you're talking about bed mass, what does the B stand for?
Brackets.
I tend to do that first. You know what? It'll work here too. Inside the brackets, how many P's are there?
1.
How many O's are there?
1.
How many O's are there?
Oh, 4.
So inside the brackets here, how many atoms? 5. How many 5 atoms do we need? 2 for a total of what? 10. How many 13, which no one said, sorry, no candy. I had to walk you through it. Like I said, the level of difficulty, sorry, Grace, and I can't change this, jumps pretty fast. If you went, wow, don't worry, you're normal. Let's try another one. Lithium Chromate. Okay. You know what? I'll do that over on the left because I got room. Li. Lithium I've memorized because I use it so often. That one's plus, yes? Chromate, not dichromate. Chromate on the back of my sheet is CrO4. 2 negative. When I use my crisscross rule. Oh, this is nice because how many CrO4s am I going to need?
1.
So am I going to need to use brackets this time?
No.
Nope. But how many lithiums am I going to need?
2.
2 CrO4. Not going to bother putting brackets or 1. And again, you would call that lithium chromate. So I think you folks have, how many more? Yeah. 5 more. I'm going to pause the video. I'm going to freeze the screen. Try these 5 on your own. I'll give you about 60 seconds, and then we'll see if you folks did it right. Who's calling my beloved name? Go ahead. First one, second one, third one, fourth one, or fifth one? Fifth one, lithium phosphate. Yep. So I went like this. Okay, so you ready? I went like this, and I know it's that. And then I said PO3. What's the ion charge on PO3? Just isn't it just negative? Oh, 3. Oh, sorry, 3 negative. So I said, okay, this is going to end up here. There's going to be 3 lithiums. What's going to end up down here? A 1. And what you were away last day, we said, you know what? If there's a 1, we just ignore it. Just like in math, when you have a 1 in front of an x, you don't really write the 1 in front. Because when I crisscrossed for this one, I ended up with, this is good questions. So Mg has a charge of 2 plus. OH has a charge of 1 minus. 1. Am I going to bother writing it? Say no. Here, what ends up down there? A 2, and I have to show that I need 2 of that whole thing. And that's where the brackets come from. Don't worry, we'll get you there, okay? We're going to keep going, though. You know what? You know what I would do if I was mean? What does it say in your notes? What would I do if I was mean? Oh, let's go multivalent. Okay. Here we go. All right. Well, I certainly know that hydroxide is OH negative. I know copper is Cu. Oh, you know what? They want me to use that charge because there's a Roman numeral 1. Okay? Again, and this is for Brooke who was away, but for all of you, notice copper has more than 1 ion charge. They have to tell me which one they want me to use. So that looks really messy. Let's try that again. Let's just put a plus there. Oh, this is going to be a nice crisscross because, Cole, what's going to end up below the hydroxide? A 1, which I'm not going to write, and a 1. Oh, this one actually works out really nice. It's going to be CuOH. Now, you would read that not as copper hydroxide. You would read it as copper 1 hydroxide because copper can also apparently have a charge of, I think, 2. And you would then need an extra. Okay. What do we put for the positive and negative ion? In the formula, we don't care about the plus or minus. We just want to care about how many you need. And the crisscross trick tells us how many we need. Oh, your notes say what? Oh, you got a bigger chart? Oh, you got more than. Okay, I just realized. Let me just see if I got this here. Okay. Well, I got some of these. I got the irons, but I'm missing one of the coppers. Is that what you're saying? Yeah. No. Oh, you know what? I got iron 2 acetate twice. So this one here is, first of all, let me fix this. It's copper 2 hydroxide. Sorry, I think I must have changed your guys' copy and forgotten to change my PowerPoint copy. You know what? For the, I would write, so you have room, Hannah, I would put this for the positive ion, Cu plus, I would put OH negative, and then you can kind of do a long distance crisscross. Is that okay? Pardon me? And then there's space for formula, there's the formula. Yeah. I'll do this. So you guys have a little thing there and a little thing there. So if I was doing copper 2, I would do the ion charge Cu2 plus, OH negative. That's what goes there. Sorry, guys, I'll fix that next year. Flunk my course, it'll be better. Is that okay, Hannah? So you know what? I'm going to get Cu, one of them. But how many OHs am I going to need? 2, and Brooke, because I need 2 OHs, what I do is I put it in brackets and I say I need 2 of them. That's where the brackets come from. And then I think I'm correct. The next one you guys have is lead 4 dichromate, yeah? So I'll go like this, I'll go like this. Lead, PB, multivalent. Oh, no, they told me 4, that's the charge they want me to use. Dichromate, that's going to be Cr2O7, and it has a charge of, sorry, what? 2 negative? Okay, I'm going to have to be really, really careful here. When I crisscross, going to be a 4, going to be a 2, or what is there? What was the final step I had to remember in my crisscrossing? Reduce. I'm not going to write 2 and 4. I'm going to go like this. PB1, I'll erase the 1 in a second because normally we wouldn't write it, but just to show you that's what I thought. And then Cr2O7. How many of them, Cole? 2. And I'll ditch the 1. Oh, figured. This is the crisscross, and it's really, I should always just say crisscross reduce, not just crisscross. Let's keep going. Let's keep going. Iron 2 acetate. Oh, there I've got the columns properly. So for some reason I just didn't. Okay, that's weird. This is going to be Fe2 plus. Acetate. What the heck is... Oh, Chaku. CH3COO minus. Cole, ask your question because it's a good one. So you're going to find if you really want to delve or dive into the black hole that's chemistry, there's all sorts of naming conventions. I'll call them sub-naming conventions. Within the rules that I've given you, turns out acetate is a solvent and it belongs to a special group of subchemicals. And for that special group of subchemicals, because it's also organic, it's traditional to write the carbon at the beginning. It's traditional to write the hydrogens next. And then the COO is actually a polyatomic ion, I think, that you don't know about that actually bonded with it. And so they kept it separate. You know what? Carbon, when they write carbon change, for some reason, they keep the O's separate. What that actually, if you were like a Mr. Perugia chemistry nerd, because he knows far more chemistry than me, that actually tells you what the molecule looks like. There's a carbon atom. It's got a hydrogen atom bonded here, here, and here. Carbon needs one more bond. There's another carbon atom bonded right here. And that carbon atom has an oxygen, and one more. You know what? Let me draw this. Don't write this down, since you asked. Okay? Ready, Cole? Yeah. There's a carbon atom. Carbon needs 4 bonds because it wants to gain or share 4 electrons. Okay? Well, it turns out there's 1 hydrogen there, 1 hydrogen there, 1 hydrogen there. Can you see where the CH3 tells me that? Carbon has 1 more bond. You know what? It's bonding with a carbon there too. Can you see how I figured that out? The C. Now, carbon, this carbon also needs 4 bonds. It's got 1. It has 1 more with an oxygen, 1 more with an oxygen. It needs 1 more. That's why it's negative. It's got 1 more negative bond to bond. That's why they write it that way. And okay, I guess that's kind of useful if we really want to dive into what these molecules look like, not just how they combine. Okay? It's a good question. You kind of got me off on a nerd tangent. Well played. Meanwhile, Cole, I think when I crisscross, I think it's going to be Fe, one of them, and then Chaku, two of them. There's iron 2 acetate. Whew. By the way, what is acetate? Girls probably know. Isn't I think acetate's nail polish remover. Go look at the chemical. Look, it's got a chemical thing on the side. You can start. By the way, if you now start to read chemical labels, you'll start to recognize. Oh, I've seen some of these kicking around now. So there you go. Iron 3 acetate. That's going to be Fe3 plus. Chaku minus. Oh, you know what? Iron 3 acetate is going to be exactly the same as iron 2 acetate, except instead of a 2 on the outside of the bracket, what's going to be on the outside of the bracket? A 3. Cool. I almost could have probably maybe even done that one in my head. Nickel 3 perchlorate. Okay. Nickel, well, that's Ni. Nickel is multivalent. Oh, no. 3 plus. Perchlorate. I have no idea what the heck that is. Oh, there it is. ClO4 negative. Okay, when I crisscross, I guess I'm going to end up with 1 nickel. And then how many perchlorates? 3. By the way, how many atoms are there in that molecule? How many inside the bracket? 5 times 3 is, plus 1 is, nice. Okay, how many atoms make up iron 3 acetate? Ooh. 1, 4, 5, 6, 7, 21, 22. So now, I told you there's molecules that are millions and billions of atoms long. These are considered little small fries still. Cobalt. I know cobalt is cobalt CO or CB? I think it's CO. CO? Okay. And it's multivalent, yeah? Well, thank goodness they told me it's 2+. Cyanide, that's near the top. I remember that one. It's the CN rail. Cross. Okay, this is going to be CO, CN in brackets, 2 of them. Whew. Manganese 4 okay. I always got to be careful. I get magnesium and manganese mixed up. Manganese, is that Mg or Mn?
MN.
It's Mn? Okay. I've got that one mixed up many times. Mn, and it's multivalent. Oh, no, I'm going to use 4+. Perchlorate, 8 perchlorate. It's near the bottom somewhere. Oh, there it is. Cl O4 negative. And again, when I crisscross, I'm going to need 1 manganese and 4 of those. Hey, how many atoms does that molecule have? Nice. See, by the way, this is sort of like some of the brackets and FOIL and thing you guys are learning in Math 9 too. Kind of cool. Mn bracket C lowercase l uppercase. You know what? I'm just going to say ClO4 in brackets with a 4 on the outside. So, I'm probably, when I see you guys on Tuesday, going to give you folks a quiz on naming. Says you'll be allowed. Says do you check your understanding, page 95, numbers 4 to 6. Let me just see if I am going to assign that or not. Let me pause the video here. I'm going to write this in your notes. Your homework, you can cross this out. Did I put this in your notes?
Nope.
Okay, so your homework. First, finish the sheet I gave you last day, which was called section 3.2 homework. And then from the text, you can do page 90, practice problems. Can I abbreviate practice problems for the rest of the year as PP, and I'll abbreviate check your understanding as CYU, and reading check as RC. So practice problems, number 1, and then page 91, practice problems, number 1 and 2. And the answers are in the back of your book. So check your work, please. The answers are in the, if you want to, I can even be more specific. Where did I find the answers? They were on page, and then I'll give you your book back in a second. By the way, the reason I don't often assign stuff from the textbook is I really think you guys should have answers to be able to check. For Pete's sakes, I did find it. Come on. Come on. There we go. Page 509. On page 609? 509. Yeah, that would scare you. So check your work. Make sure you're doing it right. But don't just be foolish and copy. Okay? I've thrown a whole bunch of information at you in the last couple of days. So practice this. You got lots of time. Use this to practice.